Hello everyone, myself Dr. Santimay Kundu. I welcome you to this lecture of soft computing technique. This is the second lecture of module 3. Till now, we have covered module 1 and module 2. In module 3, in the first lecture, we have studied some portion of fuzzy rules. We have seen generalized modus ponens, generalized modus tollens. We solve few examples and we will study fuzzy inference system. So solve few questions based on fuzzy rules. So the first example, you know that the rules of modus ponens. So here if x is a, rule is that if x is a, then y is b. Fact is x is a dash. So conclusion is y is b dash. So we need to calculate the value of b dash. It is given a, b and a dash will be given. All these are fuzzy sets. So here we consider a fuzzy set a, which is 0.1 by x1, 0.9 by x2 and 0.0 by x3. Here b is 0 by y1, 1 by y2, 0 by y3. So we need to find the value of b dash for given a dash. So the a dash is slightly different from the fuzzy set a. Suppose if I say the a is represents in some example a is represents low temperature, so maybe a dash will be some pleasant temperature, so that is something different, pleasant temperature like this. So we need to get the output for that b. So here first we need to find the value of r, which is a cross b union a complement cross y. So this is a is given 0.1 by x1, 0.9 x2, 0.0 by x3. So a complement will be 0.9 by x1, 0.1 by x2 and 1.0 by x3. And y is a fuzzy set which membership value all are 1. So 1 by y1 plus 1 by y2 plus 1 by y3. So now find a cross b. So here row is x1, x2, x3. In column y1, y2, y3. So need to find the minimum. So 0.10 minimum is 0, 0.9 and 1 minimum, 0.1 and 1 minimum is 0.1, 0.10 minimum 0, 0.9 with 0, 0, 0.9, 1, 0.9, then it is 0.9 with 0 minimum is 0. Similarly for x3 everyone becomes 0 because that is 0.0. Similarly a complement cross y, so a is 0.9, x1 0.9, so everything is in y is 1, so 0.9 is maximum. Similarly 0.1 is the minimum. Here 0.1, so x1, so say y1, y2, y3 all are 1, so 0.9 become minimum, so it is 0.9, 0.9, 0.9. Here minimum value is 0.1, here minimum value is 1, so we got a complement cross y. Next R is that a cross b union a complement y. So find the maximum. So here 0.9 first row, second row is 0.1, 0.9, 0.1, third row everything is 1. So as I said, this is the R. So this is given a dash, some value of the a. As I said, if a is the given as low temperature, so a dash may be some moderate temperature, maybe pleasant temperature, etc. So that a dash is given 0.3 by x1, 1.0 by x2, 0.0 by x3. So you need to find the value of b dash. So that is a dash min max composition. You can write it a max min compositions. So a dash max min composition are So it is 0.3, 1.00. So here the minimum value of 0.3 and 0.9, the minimum value will be 0.3. Next is 0.1.0 and 0.1 is 0.1. Next is 0. So maximum value 0.3. So it is the 0.3. The next is 0.3 and 0.9, 0.3, then 1.0, 0.9, 0.9, and next is 0. So maximum value is 0.9. So it is 0.9. Similarly here, the max minimum of 0.3 and 0.9, so that is 0.3, then minimum is 0.1, then minimum is 0, so maximum is 0.3. So that is the max min composition. So here output is 0.3 by y1 plus 0.9 by y2 plus 0.3 by y3. So that is it does. So let try to solve another example. So now try to understand the example 2. So A represents 1 by 0, 0.5, 0.9 by 5, 0.3 by 10, 0 by 15, 0 by 20. So it represents something A value with some low score. So whenever low value is 1, if it increase value is 0. B also represents with some low value, so that is something like that. 1 by 0, 1 by 5, 0.5 by 10, 0.1 by 15, 0 by 20. Now, rule is that if X is A, then Y is B. So R is A cross B union A cross Y, where A cross is complement of where A complement is. So R is A cross B union A complement cross Y. So A complement is that 1 minus mu A, so that is 0. This is 0, 0 by 0. This is 0.9 by 5. This is 0.7 by 10. 0, so that is 1 by 15. This is also 1 by 20, and in OI everything become 1, so every membership value is 1. So now here you need to find A cross B, so that is the value of A cross B, 0 by that minimum of these two. So here the minimum of so 1 minimum is 1, minimum is 1, minimum is 0.5, 0.1, 0. Similar way, this is the minimum value. So for A complement cross Y, this is the value. Now we need to find the union of these two. So the R is A cross P union A complement cross Y. So that is the value of R. The given A dash is 0 by 0, 0.4 by 5, 1 by 10, 0.4 by 15, 0 by 20. So here the value of B dash will be A dash max min composition are this O represent max mean composition. First to find the minimum value, then we find the maximum value. So here minimum is 0, 0.4, 0.7, 0.00, so that is 0.7. Similarly, second also 0.7, this one also 0.7, fourth one also 0.7, this is also 0.7. So output is 0.7 by 0, 0.7 by 5, 0.7 by 10, 0.7 by 15, 0.7 by 20. So this is the relations. This is the example of modus ponens. So I hope you have understood the fuzzy rules. So let's start with the general framework of a fuzzy system. Let's start with the general framework of a fuzzy system. So in fuzzy system, first we need to give the Cripps input. So that is become fuzzification, and that is fuzzifier. Then there is a fuzzy rule base. Then there is defuzzification, or connect with fuzzy inference mechanism. So from the Cripps input, after doing all these things, we'll get a Cripps output. So now try to understand that fuzzy inference is the process of converting fuzzy input to fuzzy output according to fuzzy rules in the knowledge base. A fuzzy inference system, that is FIS, tries to formalize the reasoning process of human knowledge by means of fuzzy logic, that is by building fuzzy if-then rules. As I said, fuzzification module that is transform the system's input which are Cripps number into fuzzy set. This is done by applying a fuzzification function. Then knowledge base store if then a rules that then knowledge base it stores if then rules provided by expert. Inference engine it simulates the human reasoning process by making fuzzy inference on the input and if then rules. Defuzzification module transforms the fuzzy set obtained by the inference engine into a Cripps value. So why should we use fuzzy inference systems? Fuzzy logic does not solve new problems. It uses new methods to solve everyday problems. Mathematical concepts within fuzzy reasoning are very simple. Fuzzy logic is flexible. It is easy to modify a fuzzy inference system just by adding or deleting rules. There is no need to create a new FIS from scratch. Fuzzy logic allows imprecise data. It does not work with uncertainty. It handles animals. It handles elements in a fuzzy set that is membership values. For instance, fuzzy logic works with he is tall to the degree 0.7 instead of he is 170 centimeter tall. Fuzzy logic is built on the top of the knowledge of experts. It relies on the know-how of the ones who understand the system. Fuzzy logic can be blended with other classical control techniques. Some classification of fuzzy inference methods. Fuzzy inference methods are classified in direct methods and indirect methods. Direct methods such as Mamdani and Sugeno and Sukamoto type inferences are the most commonly used. These methods only differ in how obtain the outputs. So indirect methods are more complex. So in conclusion, today we have understood some examples of fuzzy rules. We have understood that some introduction of fuzzy inference system. So today question is that assume a fuzzy set represents low temperature. B fuzzy set assume that B as low pressure. Now if X is A, then assume Y is not B, not B. So for this is rule. Fact is that X is some fuzzy set A dash. Find Y is B dash. So assume any fuzzy set and try to implement this thing. So these are the references for today's class. Thank you. Have a nice day.